Alright, it's time I introduce another data type to you. This one is called the dictionary data type. It's similar to the lists, except in this case each element inside the dictionary is comprised of a key value pair. What that means is you have two items, two parts to each element in the dictionary. Your key is what identifies the element, and the value is the value that you want stored. Okay. And here's the syntax for declaring a dictionary. It starts with these curly braces, not with the square brackets like a list. So it starts with these curly braces, and then you have this sort of structure here. Your key goes first, and then your value goes second, and they are separated by a colon. Okay, and then each element is separated by a comma. All right. So that's the syntax there for a dictionary. You're able to access elements inside the dictionary in very much the same way as a list, except in this case you specify the key that you want for the value that you want, and instead of passing in specifying an index, an integer value for the index. So in a list, if I wanted the first item, I would put the index of 0 because that's the first element in a list. But in this case, in the dictionary, it's not really ordered. It's just everything has a key to it. So you tell it what key you want, and then Python will look inside the dictionary, locate the key, and then return the value for you. All right. So let's kind of see, run this and see what happens. This should print out pencil, because pencil is the item name, is the value associated with the key item name. All right. Now you're also able to modify elements in the dictionary using the same sort of syntax. So you'll specify your key just like normal, and then you assign it a value instead of just reading it. So in this case, I told Python to just go get that value for me. In this case, I'm telling Python to find this element and then assign the value to it. Now, since this key already exists, what Python will do is update the value. So originally I had 32 pencils in here because I always lose pencils. And in this case I said, you know what, 32 pencils is a little extreme. I think 28 is a little more reasonable. So let's adjust that, and we're going to set the quantity to 28, and then we'll print out just to make sure that it did indeed get adjusted. So let's see what happens. There we have it. So it prints out the value that was just updated in that dictionary, which was 28. Okay. Now, let's say you try to access an element that does not exist in the dictionary. Okay. So in this case, I'm going to try to access. I'm telling Python, hey, I want you to read that dictionary for me and find the key of expires. Okay, well, you can see from my declaration here that key is not in the dictionary. So let's see what Python tells us. There we have it. Key error, expires. So Python's telling us that the key that was specified, expires, does not exist in the dictionary. Okay, now so you just have to make sure that anytime you're reading a value from the dictionary, that it does exist. Okay, but you can add elements to the dictionary using this same syntax that we did to update. So you'll do your dictionary, you'll pass in the key that you want to add in this case, and then a value to assign to it. Now, when Python does something like this, if the key doesn't exist, it'll add it and then assign the value that you're assigning to it. The reason that threw an error before was because we were trying to access an element or to read it, and it didn't exist. When you're trying to assign a value to it, Python will automatically add it if it's not already there. If it is there, then it will just update it. Okay, now something I want to mention real quick too is you want to make sure that you only have one key, or each key is unique, that is. You don't want to have something like this, right? And that's just because when you go to access the element of item name, Python's not going to know which one it is. You may get pencil, you may get paper, who knows, right? Because Python doesn't know which one you are talking about. So you probably won't get an error for doing that, but it'll just cause some unwanted behavior. And then when you go to update it, who knows which one it's going to update, right? So try to make sure each key is unique, and don't try to read a key that does not exist. Okay. So let's see what happens. In this case, I'm going to go ahead and add an element of 1.19 to my dictionary and assign it the key of cost. Okay, and then I'm going to print out that value. There it is, 1.19. Now, some people may be tempted to do something like this in their code. It's not going to cause an error. It doesn't actually really affect the execution time or anything like that. The only thing is it's a little bit redundant. It's an added step. Python does already interpret this 1.19 as a float. You can see as I hover over it, Python says, hey, it's a float. So casting it to a float is just redundant. So I don't have that now. It still recognizes it as a float. This one up here recognizes it as an integer, so there's no need to cast that using the integer cast. That's just redundant. All right. Now, there is also a ability to delete an item from the dictionary. That's done using the del keyword, which is short for delete. Imagine that. So you just say delete, and then you pass it the dictionary with the key that you want to delete, and Python will locate that element, that key in the dictionary, and then delete it. All right. And then let's see what happens here. And actually, I'm going to do, just so you can see what the value is before and after. We're going to print the value of my dictionary, then we're going to delete a value, and then we're going to reprint the value so you can see that it is being changed. There we have it. So that's our unmodified list, our dictionary, and we deleted an item, and now you can see that the color element is now deleted. It is no more. So that's how you would delete an element inside a dictionary. Okay. Now, one last thing here. You can also you can loop through a dictionary just like you can through a list. The difference is you want to specify this keys value here, the keys method or function. So you structure your loop just like you do for a list for I in my dictionary.keys. And then what this will do, this actually just returns all the keys. So if we come up here, you'll see it'll return this one, the item name, quantity, and color. Although we deleted color and added cost, so it's going to return item name, quantity, and cost as the list of keys. Okay, so this does return a list value here. So then what it'll do is it'll just loop through each element inside this list of keys and set the value to I each time, starting with the first and moving on. Okay, so now when I call this print key value, and this syntax might be a little foreign to you, so let me explain that kind of real quick. So this with the percent and the S is a format specifier. What that means, it always starts out with a parenthesis or with the percent sign. The S signifies that it is a string type, and so Python will convert any value to a string. And that's just the placeholder then. So now what I do after the entire string, so here's my whole string with the specifier, the format specifiers inside. And now outside of the string I have this another percent sign followed by the group in parentheses of values to substitute. So it does it in order, so the I, which is the first element in this substitution list, is going to be replaced with the first placeholder, and the second element inside this this group is going to be substituted in for the second placeholder in my format string. Okay, and then what this is doing is I is being set to the key each time, each key of the dictionary, and then what I'm doing is I'm accessing the value inside the dictionary using that key and bringing that out. And then we're just spitting up the data inside the dictionary. So let's run this and see what happens. There we have it. So the key that was processed on each iteration, item name, quantity, cost, and then it's returning the values for each of those. Okay, so that's the dictionary type. It's very versatile, very powerful, and very useful. So basically it's similar to the list type, except you don't specify an index for in order to access the value. You specify the key associated with the value that you want.